ultraviolet radiations, the radiations which are found beyond the violet end, is called ultraviolet radiation. So in case if you have a glass prism, mind you, I am using the word glass prism, and you throw on it a white light, I will use a black color to show you a white light, then you will, don't mind if I say it splits up into the component colors, that is into the kind of a red color, into kind of a violet color, and all 7 colors in between, which I am not showing because of scarcity of space. So this is the red end and this is the violet end, and this is the screen on which the spectrum is obtained, and you can see only the red and the violet color on the screen. I mean all the colors also in between, whatever are there on the screen, and rest portion of the page or the screen is all empty, means all colorless. Now if you replace this glass prism by the quartz prism, quartz is a material, you must have heard of the name, used in watches to give you the kind of a visual effect. Quartz watches are there, and quartz material. So if you use a prism made up of quartz, then you will see that still the same visible colors are seen on the screen, and nothing is seen on this end or that end. But if you take in a test tube silver chloride solution, silver chloride otherwise is a clear solution, it's a white transparent solution, you take a silver chloride solution and try moving it from the beyond the red end towards the visible end, and then beyond this violet end, you will see that the clear nature of the solution will not be affected if you are moving it towards the red end from the invisible spectrum part. And still you will find no change. If you move this into this direction, you will see that still there will be no change in the color or the appearance of this transparent silver chloride solution. But as soon as you move beyond the violet end, you bring it here, this test tube, you will see that the colorless silver chloride solution will in no time turn into violet color, and then ending up into the dark brown or the black color, indicating that there might be some invisible radiations which are present beyond the violet end, which are chemically very active, and that radiations have affected this transparent silver chloride solution. Okay, so this was a test, this was a way how to find or how to deduct the presence of ultraviolet radiations in the ray of light which is coming. That is the reason why we have window panes in various houses, in schools and everywhere, made up of glass, because glass stops not only the infrared radiations, it also stops the ultraviolet radiations. All those radiations are absorbed by the glass. So therefore you need a special kind of a quartz glass which allows the ultraviolet radiations to pass through and can be detected by this means, by means of an experiment. This is about the detection of the ultraviolet radiations. I hope this is clear in your mind, and I was expecting a better response that side. You can even detect the ultraviolet radiations by way of its reaction on the dyes or the photographic plates. If kept in open, dyes gets affected, their color changes when it is kept in open to the atmosphere. So the basic sources of ultraviolet radiations are electric lamp, that is electric arcs, sparks. Sparks also gives ultraviolet radiations. A part of light coming from sun also is ultraviolet, and a large fraction of it is actually, the ultraviolet radiation which is coming from the sun, a large part of it is absorbed by the ozone layer present around the earth. So but that ozone layer is being depleted with time, and therefore our danger to get exposed to ultraviolet radiation is increasing. This ozone layer protects us from the harmful effect of the ultraviolet radiations. But due to now the large pollution, there is depletion in the ozone layer, which is dangerous for us because we can be now have a greater danger of exposure to the ultraviolet radiation, which are harmful rays. They can cause skin cancer. So the harmful effect of the ultraviolet radiations are that is their overexposure may cause skin cancer if we expose to the ultraviolet radiations for longer durations. Uses of ultraviolet radiations are many. They are used for sterilizing purposes, that is for sterilizing air. These days we badly need sterilizing of air. Surgical equipments in hospitals, etc. also can be done using the ultraviolet, the devices which can produce ultraviolet radiations. Ultraviolet radiations are also used for detecting the purities of gems, ghees, eggs, etc. in industries wherever these are been supplied or tested. So they make a great use of ultraviolet radiation to detect the purity. In the production of vitamin D in foods of plants and animals, ultraviolet radiation holds a great use. So this is, guys, all about the ultraviolet radiation which I have spoken about. Coming to the visible light, this also we didn't discuss yesterday, and we have discussed about the visible light in detail. We said that it is a visible kind of a thing, which gives us the sensation of sight, and having the wavelengths all between 4000 angstrom to 8000 angstroms, and this makes us to see the things around us. This visible part of the spectrum was discovered by Newton while passing the sunlight through a glass prism. The prominent colors are in the reverse order of Webcure. We have done that experiment previously. Sources of visible light are sun, electric bulb, flame, white hot bodies, etc. Uses are basically in photography, in photosynthesis, and in looking on the objects around us. Making us eligible now to study about the infrared radiations. Again, I'll ask you to see on my whiteboard, if you can see that if this glass prism, which we have replaced by the quartz prism, instead of quartz prism, if we replace it by the rock salt prism, kind of a salt which is used in cooking foods. So if you replace this glass prism by a rock salt prism, then if you try bringing a blackened bulb thermometer, is nothing but a thermometer only. Have you ever seen thermometer in your life? That not only gives me a suggestion that you have not seen, but also you are present or not in the class. Have you seen a thermometer in your life?
Yes, sir.
Okay.
Yes, sir.
Okay. Very life-saving kind of a yes is coming my way. That is a blackened bulb. Why blackened bulb? Because black absorbs the heat more. So if you move a blackened bulb thermometer from the violet invisible spectrum, ultraviolet spectrum, towards the visible spectrum, you will see no rise in temperature, no effective much rise in temperature is seen. Temperature is more or less same. But as you go through the visible end also, it shows a partial rise. Like here, it shows a partial rise, a small rise in temperature in the visible section. That's a great news, that it shows a partial rise. That is, visible light also causes a little bit of rise in level. See, it was here and it has risen by a small portion in a visible light. But as soon as you go beyond the red end, my God, what happens is it shows an immense rise in temperature. This blackened bulb thermometer shows a sudden great rise in temperature. This was initially, and then it rose in the visible light, and then it rose further. So you saw a much rise in the temperature when you move from the violet end towards the red end and go beyond the red end, it shows a great rise in temperature. So that means there might be some radiations present beyond the red end which have a heating capacity, which has a tendency to heat. So these radiations are basically of the type which can produce a lot of heat. So therapeutic purposes it can be used for, that is heating purposes it can be used for. So these were then termed as infrared radiations. Infrared, infra because their frequency is less than the red color, therefore infra, and red because it is on the side of the red. And the whole spectrum on this side is called infrared spectrum, which consists of infrared rays, which consist of microwaves and radio waves. So this is how it was discovered, how when these these radiations were detected. William Herschel in 1800 detected it. A thermophile can also be used in place of thermometer, that is more sensitive than a thermometer, and a rock salt prism is used instead of glass, as I suggested. Sources of infrared radiations are all red hot bodies such as heated iron ball, flame, fire, etc. Sun is a natural source of infrared radiations. Many properties of the infrared radiations are there, as there are many properties of the ultraviolet radiations also, which I skipped through a little bit in order to compare this slab by which, like a quartz prism is used for the ultraviolet radiation and the rock salt is used for the infrared radiation. Now two uses and two properties must be there in your mind. So when you are naming those properties, that is, say you are using you have to name the properties of the ultraviolet radiation, please don't name that they travel with the same speed as that of light, that is 3 to 10 to the power 8 meter per second, or they reflected and refracted, and these are the properties common to all electromagnetic spectrum. When they ask for two properties of ultraviolet radiation, please name the specific two properties which are unique for their existence. That is the one which is given as these ultraviolet radiations are scattered large by dust particles present in the Earth's atmosphere, while infrared radiations on the other hand are scattered the least, are not scattered much owing to its large wavelength. Infrared radiations do not scatter much. So this is one interesting property which you must know with regard to when you are asked to give one property. So you can give this property, or maybe you can go for this property that they are chemically very active. Like ultraviolet radiations are chemically very active, and they can pass through quartz, but they are absorbed by the glass. This is one property you can give. While in case of the infrared radiation, you can give that it has a heating capacity, it has a tendency to heat. They're chemically inactive, but they have a capacity to heat. Ultraviolet radiation does not heat. Infrared radiation heat. Ultraviolet radiation is chemically active. Infrared radiation is chemically not active, but it requires a rock salt prism for its propagation ahead. So give those properties which are important for which are unique for their name, and not the common ones. Like for infrared radiations, you can further go on to say that they are detected by their heating property. I have right now spoken to you that it has a great heating capacity, and that these are scattered less by the Earth's atmosphere. Like for the infrared radiation, ultraviolet radiation, they were scattered more. And moreover, this is one radiation, I'm talking about the infrared radiation. This is one radiation which is absorbed by the Earth's atmosphere. The greenhouse gases such as carbon dioxide present in the Earth's atmosphere absorb these low energy infrared radiations and keep the Earth's surface warm. So they might test you by this, that is, name the radiation which is absorbed by the Earth's surface. So you have to name infrared radiation, only when you know or you've read all these properties. Harmful effect of infrared are any, in fact not any, are none. In fact, they only can cause a little bit of skin burn if you are overexposed to the sunlight. Uses of infrared radiations are many. I mean, they are used for the therapeutic purposes, used as suggested by doctors. So because it has a heating effect, you can try your clothes, you can try your quilt, you can try anything which is little moisturized. You can use this. You can use ultra infrared radiations in photography at night, or also in mist and fog, because they are not much scattered, so they can penetrate appreciably through it. Infrared lamps are used in dark rooms for developing photographs, as they provide some visibility without affecting the photographic film. This is a very, 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 very important use of infrared lamp, infrared radiations. That is the infrared lamp. They are used as signals during the war. This is again a very important use. That is, these are used as signals during the war, as they are not visible and they are not absorbed much by the medium, so they can travel appreciable length. They are also used in remote controls of the television and other gadget. And I met another student the other day who was saying, "Sir, I can see that infrared rays in the remote control." So my kind submission was that you can't see infrared radiation at all, because that is not visible. What you see is the red LED bulb on your mobile, on your remote, or maybe on the television. You can see that red LED glowing. But what you can't see is the radiation which is coming out, which is going to the television and making the electronic component of the television work. So okay, so if that is a kind of a myth in your mind, you can clear it. Distinction between the ultraviolet, visible and infrared radiations can be summed up like this: that ultraviolet and infrared are invisible spectrum, while visible is a visible spectrum. Infrared are less than 4000 to infinity on the lower side, and 8000 to positive infinity this side along the wavelength, while visible is only limited to 4000 to 8000 angstrom. Ultraviolet radiation does not produce any heating effect. Visible produces a slight heating effect, while infrared produces a strong heating effect. Ultraviolet and visible affect the photographic plate, while infrared radiations does not. Ultraviolet radiation can cause fluorescence, while visible and infrared does not produce any kind of fluorescence. Ultraviolet can cause health hazards, visible do not. Infrared radiations does not affect the body. Heavy doses might cause some skin burn. Ultraviolet radiations can pass through quartz prism. Visible can pass through all the kind of prisms, including glass prism, and infrared radiations can pass through the rock salt prism. So this is all I had to offer you.